If you're studying for Exam PA, I want to see if you can beat me to the answer. In my past 2 study with me videos, I read the question, I gave you my attempt, I gave you my answers, and I gave you key takeaways. For this video, we're going to be switching it up. Switch up number 1 is obviously the location. I'm currently on a work trip and I thought there would be no better time than the present to take you guys with me as I'm actually studying in real time. And so that's why in this video, we're gonna do things slightly differently. I will give you the question, you're gonna have to work through the response on your own, and then I'll reveal the answers to you and we can break down the subject into a deeper level and have key takeaways that we can actually truly understand instead of just memorizing. So grab your notes, grab your flashcards, and let's see how many you can get right. Welcome to Glowing Together. Explain 2 typical uses or applications of exploratory data analysis. Number 1 is data validation, to check and identify potential errors in the data that may lead to unreasonable model results. Number 2, to know the key characteristics of the variable in the data. This may suggest useful ways of pre-processing the variables to improve predictive performance and interpretability of the models. As far as the key takeaways, I think for card number 1, the first one they gave was data validation, and this is really important in the actual field. So as a senior actuarial analyst, we see a lot of times data, and when you're pricing products, when you're really doing a lot of things, you're always validating the data. You want to make sure that you have the correct information. You want to identify nonsensical data values, something that's unreasonable. That is a huge word that is always used, I feel like, in the workplace is unreasonable. Oh, does that look reasonable? Is this reasonable? So you should remember that. And then outliers, so you don't want things that don't really make sense to your overall picture or could like mess with your model if it's some sort of event that doesn't typically happen. So for example, something that I always hear about when pricing insurance products, especially healthcare, when we're looking at our descriptive, our past, come on guys, you guys were here for flashcard 1. For chapter 1 flashcards, you already know we started off with descriptive. So that means past data, right? We know this. So our descriptive data or our descriptive analytics show oftentimes, COVID. Like COVID was kind of an outlier. Those years kind of mess up our data a bit when it comes to trying to predict the future, because that was sort of like a one-off event. And so when you're validating data, you're looking at certain things like that, trying to decide whether or not it's reasonable to include those time periods in our prediction models, even though that was kind of like a one-off event. Another thing I think is important that they didn't add in there is, because I read this in the text, is that you're doing this data validation essentially to be able to remove things. When you're validating data, you want to remove those pieces of data that are not helpful. Explain the pros and cons of using descriptive statistics and graphical displays in exploring data. Pros and cons of summary statistics. Pro, it's precise and objective. The second one is they're easily comparable across variables. The cons are they can only capture a certain aspect of the variable's distribution, not the full picture. And some statistics, such as your mean, can be easily distorted by outliers. Pros and cons of graphical displays. The pros are that users can gain a quick visual impression, and they can reveal information not easily represented by summary statistics. The cons of this are that the information provided is not as precise as summary statistics, it's less comparable across variables, and poorly designed graphs can be hard to read and interpret. I think the pros and cons are pretty straightforward, but if there is anything to take away from this, it's just that this is a very important topic. Within the manual, it actually says that EDA is tested in each and every PA exam. So that clearly tells you the level of importance that this topic has. So as we continue to go through, just make sure that we're really paying attention to this section. This section involves a lot more graphs, so just understanding what you're seeing and being able to interpret and identify what these graphs are trying to show you and what the different use cases for these graphs will be is going to be hugely important, because obviously this exam is a lot more real world focused. For example, here in the manual, it's giving us a bunch of the different past exams where they do use EDA. They've used it October 2025, April 2025, October 24, April 24. So it's clearly on the exam a lot. And to give you an example of one of these questions, it would say something like, complete the table below, identify an appropriate bivariate graph for each pair of variables. And then part 2 would say, explain what kind of insight could be gained from each graph. And I just read that to you. It doesn't have the answer here right now, but I'm reading that to you so that you can kind of get into the mindset that you need to have while doing these flashcards of, okay, more than just a flashcard, I need to truly understand where this will take place in real life. That is going to be a major key, I think, to passing this exam, is being able to take something that you once just knew off of definition and being able to apply it to the real world. Card number 3. Explain how a histogram can be used to visualize the distribution of a numeric variable. A histogram divides the observations of a variable into several equally spaced bins and provides a visual summary of the number of observations in each bin. For the histograms, the key takeaway is going to be visualize distribution, and that it's a numeric variable. And then we're also going to have that the observations are divided into equally spaced bins. Equally spaced bins. So I know this seems really simple, but then there's things like bar charts and histograms, and like there are different types of graphs that look similar. They have different names, so you're gonna have to lock in. Okay, something else that wasn't included on the flashcard, but I think is important since we're starting this topic, is that this is for univariate data exploration. So that's kind of the subject matter that we're currently in. And that just means that we're going to be looking at the distribution of one variable at a time. For me, at least, I don't know about you guys, but when I think of graphs, I don't always think distribution. So that's something that I think we need to kind of add in there, that we're looking at distributions. And for histograms and this current topic, we're looking at distributions of one variable at a time. So let's use age as our variable. So we're looking at the distribution of age, and that's it, using a histogram. And so within univariate data exploration, you're going to have summary statistics and you're going to have visual graphs, and they are going to be dependent upon whether or not your variables are numeric or they're categorical. That's going to be the determining factor on what stats and graphs you're going to be using, whether it's numeric or categorical. Not the distribution, whether it's numeric or categorical. Card number 4. Explain the problems with using a right-skewed variable and predictive modeling. If the values of the observation of the target variable cluster narrowly in a small value range, it will make it difficult to investigate the effect of the predictors on the target variable globally. 2, if the target variable is right-skewed, the outliers may have a disproportionate effect on the square errors of the model. I can already tell that this one we should be looking up. We should be looking this up. Are you looking it up? You have an AI chatbot right there. Just look it up. Look at it. What are you waiting for? What are you waiting for? I think some takeaways for our last card are going to be that the right skew shows up most in the real world. That's why we have this card in the first place, in case you were thinking, why is it specifically right skewed? Are we going to get to left skewed? No, they don't have a flashcard for left skewed. They only put right skewed in there, because that is what is going to show up most in the real world. Most variables in the real world, such as income or loss amounts, are typically set up to be non-negative. So if you were to see some sort of outlier, you're probably going to see it in greater values rather than greater values that are negative. Well, technically they would be less values, but who cares? Something else important, we're calling it right skewed, which it is. And that means that looking at the graph would be going something like this and then keep going out to the right. And those right side variables that are over there are what we consider outliers. There's not that many of them. They do exist in the data, and we have to do something with them, and we need to understand why they're there. The reason why this is so important is that when you're fitting the model, many models are going to be fit using the minimum sum of the squared error, and outliers are going to influence that very heavily. So that becomes an issue with your predictive power. So those are the two things: model fitting, predictive power. And the way that we're able to solve this is to either remove the outliers, keep the outliers, modify the outliers, or by using a robust model form. And this is kind of something that we touched on in, I think it was video 2, where we were asked what was the difference, like the pros and cons or the comparison between MSE and MAE, so our mean squared error or our mean absolute error. And one of the use cases for the mean absolute error was that it's way better with outliers. So this is another, we're building upon that information. So just keep that in mind, keep building. Card 5 suggests 2 functional transformations that can be used to handle a right skewed variable. Log transformation, which works only for strictly positive variables. The remedy is to add a small positive number to each value of the variable if there are zeros. And secondly, square root transformation, which works for non-negative variables. Takeaways for this card. First thing I want to point out is in the last card, we used modify as one of our solutions, which is still true. But what we're looking at now is an alternate solution. So they're not the same. When we're talking about remove, keep, modify, and using robust model forms, it's not the same thing. Those are not the same category when you talk about these transformations. These are alternate solutions. We would be applying a monotone concave function to the whole variable to shrink the outliers, which is going to improve the goodness of fit. And you guys don't know, goodness of fit refers to your training set, not you training the model, not the model that you use when you're testing. The other thing that I would take away is that log transformations are only for positive variables, and square root transformations apply to positive variables and zeros. Neither one of them allows negative values. Neither one. I got confused with that. I thought that the square root transformations did involve negative values by the way they were describing it, but I did some additional research and that's just not the case. So let's remember that. Number 6, explain how a box plot can be used to visualize the distribution of a numeric variable. A box plot places the middle 50% in a box and represents the rest of the data through whiskers. The amount of spacing between the different parts of a box plot reflects... Why am I not able to speak English? Okay. The amount of spacing between different parts of a box plot reflects the degree of dispersion and skewness of the variable's distribution. The key takeaways for this one, I think, is a little bit different than usual because they're clearly just giving you the definition of what a box plot is, but with some further deep dives, I think that's important to note that box plots don't directly show the actual shape of the distribution. So like the graphs that we were just seeing previously, like the histogram, like a density plot, like you're visually being able to see, okay, this is how the distribution of these variables are shaking out, and there's a shape that forms. Box plots do not have that sort of shape. However, they do offer a graphical summary of the key number statistics and allows for visual comparison. I'm having a moment. All right, back to studying. Playtime over. Question 7. Explain how a bar chart can be used to visualize the distribution of a categorical variable. each level of the categorical variable, a bar is drawn whose height or length is proportional to the number of observations in that level of the variable. The heights can be reported as actual frequencies or relative frequencies. Key takeaways from this card is going to be that we are now talking about categorical variables when we're talking about the bar graph. There's going to be two different ways to categorize the data or look at the data or think of the data that matter for the bar chart. So one being whether you're given raw data or if you're being given summarized data. And when you're given raw data, typically put this into a frequency table where you can look at raw counts and percentage counts. Bar charts come into play is that the frequency tables become harder to read with the more levels that you have. So using the bar chart makes it easier to look at and you're able to see which category is most popular. Those are my takeaways. I think this is one of those that you need some visual representation. So I did go to chat, calling in chat. You know, I loved me some chat time. And chat broke this down for me in a way that was easier to understand for me. I'm gonna include that in this video so that you can see the explanation that was given to me, because when I first read this, I was so confused. I was like, is this not the same thing? But I think chat gave a better example than ACTEX manual did, so we're not even gonna look at that. We just got through a little bit over half of chapter 2. We're now going to be entering into the bivariate universe. I'm gonna save that for the next video. Let me know down in the comments below if you have any other solutions to these problems, if you have any suggestions or anything that you think that we should all be looking out for. Make sure you drop it below, and also make sure you subscribe so that you can be here for the next video where I will finish out the rest of chapter 2. If you have taken this exam before and passed it, if you've taken it and not passed it, everybody's opinion is valuable. We are all learning from each other. We're growing together. So let us know in the comments. Let's talk about it. Hopefully, if we're taking this in sitting, then we'll pass together and we'll all be coming back to these videos and we'll say, you know what, we did it as a team. We did it together. Make sure that you guys are here. How else are you going to learn? I also do want to make one quick shout out. I had with my first comments from a fellow actuarial student saying that they really appreciated this content since there's not so much out there, and that's exactly why I'm doing this. So that made me really happy. So shout out to you. Thank you so much for leaving that comment. You guys don't know how much that means to me, because I felt the exact same way and I still feel that way. There's almost no free education on the things that we need to learn about, or just even helping us to know what topics are coming up. So hopefully this series will be one little piece of the puzzle that will add some relief to actuarial students in the profession, just in general. I think it's really important to have a community to study with, because most people don't understand the grind that we have to go through with these exams. They don't understand the content. They don't know anything about anything. So I think it's about time we start a little bit of a community together here on YouTube. This can be it right here. This is the community. We're starting it, and we're gonna study together, and we're gonna get through this together, and we're gonna be credentialed actuaries. That is the goal. That's the plan. Be there or be square. And don't forget, if you're serious about ownership, start with education. And if you're serious about education, subscribe to Glowing Together. Bye!